All right, I'm going to go over the concept of an inclined plane problem. We have an object on an inclined plane here, and it's going to accelerate down the inclined plane, but there is, in fact, going to be friction. So we're going to have uh, a force of gravity acting in the x direction, and we're going to have a force of friction. Those two together are going to equal our sum of forces in the x direction. But notice what I've done here is I have taken our coordinate plane and I've changed it so that way it is with the x-axis acting down into the direction of the plane. So it's going to move along the x direction. All right, the first thing I want to do is I want to draw the force of gravity. So here I have the force of gravity drawn, and that's acting straight down. That is equal to mg, g being the acceleration of gravity. And I can also draw the components of that. So let's use some purple color. And so perpendicular to the plane, I'm going to have my y direction, and then parallel to the plane, I'm going to have my x direction. So here we have the force of gravity in the x direction, and we have the force of gravity in the y direction. Notice that the force of gravity in the y direction is going to be equal and opposite to the force of gravity. The normal force is the force of gravity is equal and opposite to the normal force. The normal force is acting in the opposite direction that I would draw up there. So I can do that real quickly. Let me just put a vector up there. And so these two forces, these two forces should be equal and opposite. I could even extend it out a little bit further. There we go. And so these two forces are equal and opposite, cancel each other out because it's not accelerating in the y direction. All right, I can keep that there. Now realize that this angle here and this angle here are the same angle. The same angle theta exists at these two locations. So when you look at the triangle, you may notice that we're going to actually use sine for the x direction and cosine for the y direction. So if we have, let's look at the x direction first. So the force of gravity in the x direction is going to be equal to sine of theta times the force of gravity. And then the force of gravity in the y direction will be equal to the cosine of theta times the force of gravity. So let me extend down a little bit. So looking at the sum of forces in the x direction, we're going to have, as I said, if I can scroll back up, I have the force of gravity in the x direction minus the force of friction in the x direction. That's clearly in the x direction. And that in turn is going to equal the ma. This is different than mg. This ma here, this acceleration is the acceleration that I am observing. I'm observing this accelerate in the x direction. It must be clear that you see that. Okay? Get rid of those. Get that back. All right, so this is the acceleration in the x direction. Make sure that you understand that is along the plane. And that, whatever that acceleration may be, it is accelerating at some rate. So there is an acceleration. It is not zero. And if we can take our force of gravity in the x direction and plug that right in. So that's going to be sum of forces will be the sine of angle theta times the force of gravity, which we can certainly find by taking the mass of the object times 9.8. And again, that's minus the force of friction in the x direction. If I add one more part to this, if you remember that the force of friction, assuming that it is moving and sliding, we are looking at kinetic frictions. The force of friction is going to be equal to the coefficient of kinetic friction times the normal force. And keep in mind that that normal force is going to be equal and opposite to the force of gravity in the y direction. So if I know the force of gravity in the y direction, then I know the normal force. So let's take this and replace that with our normal force. So if I can just take that, so the force of friction is equal to the coefficient of kinetic friction, and as I have up there, I have the cosine theta. Okay, this is going to be the coefficient of kinetic friction times the cosine of angle theta times the force of gravity. And I can now take this and plug that into here. So finish that up. I have the sum. Let me scroll down a little bit more. The sum of all forces will equal the sine of angle theta times the force of gravity minus that force of friction, but plugging in my coefficient of kinetic friction times cosine theta times the force of gravity in its place. And again, that is equal to the ma, the acceleration that I observed. If I need to, I can factor out my force of gravity. So the sum of forces can equal the force of gravity times the sine of theta minus the coefficient of kinetic friction times the cosine theta. And again, that's equal to ma. All right, so I've analyzed the forces in the x direction, and now that I realize it, let's make sure that we understand that that is in the x direction here. This is the acceleration in the x direction along the plane. So I have analyzed all of the forces in that direction. All right, so doing this at the end of the school day here with lots of interruptions, hopefully that helped a little bit. I know I didn't plug any numbers into this, and sometimes that frustrates people, but from a conceptual standpoint, looking at just the variables, that is how we can analyze the forces along the plane and relate them to the force of gravity. All right, hopefully that helps. Have a good one.